Okay, this is the first integration set. It's also a little bit late, so I apologize in advance if it feels rushed or I make any stupid mistakes, but hopefully I'll correct myself as I go. Okay, so what we've got here on our first question, we've been given f dash x. So remember, it's just another way to write things. So y corresponds, if you like, to dy dx when you differentiate it, whereas fx corresponds to f dash x when you differentiate. So if you want to go this way, you need to integrate. So that's what we're going to start off by doing. So we're going to integrate to get fx. So fx equals, when we integrate this, we add 1 to the power. So 6x squared becomes 6x cubed over 3, and then divide by the new power, ax squared over 2 minus 23x, and don't ever forget your plus c. Okay, so we've got fx equals 2x cubed plus a half ax squared minus 23x, and we're told c is 12, so we've got minus 12. And we know x plus 4 is a factor, so x plus 4 equals 0, gives you x equals minus 4. So f of minus 4 equals 2 minus 4 cubed plus a half a minus 4 squared, 23 minus 4 minus 12, and that equals 0. When you rearrange that, you end up with a equals 6. And then you have to find it in the simplest form. It doesn't ask you to factorize, so it's not necessary to. So we get 3x squared minus 23x minus 12. Okay. So the next question, we've got, let's see what we've got. So it says find the values of the constants a, b, and c. So there's a couple of ways you could do this. Again, you could make this equivalent, which is probably what I would do, was make that into one fraction. So make it all over x plus 2. So you'd have ax plus b multiplied by x plus 2 plus c. So if you take the numerators, the top bits, and make them equal, you've got x minus 8. 3 is equivalent to, so if I open this out, I've got ax squared plus 2ax plus bx plus 2b plus c. And then you can just equate coefficients. So you can see a must be equal to 1. So a is equal to 1. If we look at our x's, we've got 8 on that side. And on this side, we've got 2a plus b. So we've got 8 is equal to 2a plus b, but we know a is 1, so 2 plus b equals 8, so b must equal 6. And then we know we've got our last lot where we've got minus 3 is the same as 2b plus c. So 2b plus c must equal minus 3, but we know that b is 6. So we get 12 plus c equals minus 3, so c is minus 15. Okay, so we've got a is 1, b is 6, and c is minus 15. And then we want to integrate it. So if we rewrite this, this is going to be the same as integrating between 6 and 0. We know that a is 1, so we're going to get x plus 6 minus 15 over x plus 2 dx. So when we integrate, remember we put it in square brackets, x integrates to x squared over 2 plus 6x minus 15. So anything that's 1 over something is just ln of the bottom. And so we get ln of x plus 2. And that's between 6 and 0. When I substitute 6 in, I'm going to get 6 squared. So 36 divided by 2, which is 18, plus 6 times 6, which is 36, minus 15 ln 6 plus 2, which is 8. And then from that, I'm going to minus, well, that's going to give me 0 plus 0 minus 15 ln 2. So if I put my numbers together, I've got 18 plus 36, so I've got 54. And then I've got minus 15 ln 8, but I actually want it as ln 2. So I'm going to rewrite that as 2 cubed, minus minus plus 15 ln 2. Now, if you've got something as a power with lns, remember you can bring it down. So we can do 3 times 15, so 45. So we've got minus 45 plus 15, giving us 30 ln 2. So our final answer is 54 minus 30 ln 2. Okay, so the next question, we've got show that. All right, so if we look at that, on first sight, it doesn't look obvious. So it's not, we could use by parts if we wanted to. We could also use substitution. We could use substitution, which I think is easier. My go-to is usually substitution. Or you might have recognized it. So we're going to use substitution because I think it's easier to do. And whenever you substitute, you always substitute for the bit under the square brackets or to the power or on the denominator. So I'm going to let u equal the x plus 2. And before I even start, I'm going to do all the preparation work, which is worth most of the marks. So I'm going to differentiate it. Du dx equals 1. So therefore dx is going to be the same as du in this case. I'm going to do my limits. So I'm going to say x and u. So the limit 2, if I put 2 in, 2 plus 2 is obviously 4. And if I put 0 in, I get 2. And I'm going to say, okay, so I can substitute for that. I'm going to rearrange this for x is u minus 2, and that's everything I need. So now I can plug it all in. Instead of 2, I'm going to write 4. Instead of 0, I'm going to write 2. Instead of 2x, I'm going to write 2u minus 2. And then root x plus 2 will be u to the power of a half. And instead of dx, I can write du. Right, now I can open that out. So 2u to the half times u. So that's a half plus 1. So I'm going to get 2u to the 3 over 2 minus 2 times 2, which is 4, u to the half du. And now I'm going to integrate it. So I'm going to add 1 to the power. So I get u to the 5 over 2 over 5 over 2, 3 over 2 over 3 over 2 between 4 and 2. Sort that out. So I'll get 4 over 5, u to the 5 over 2, and that's going to give me 8 over 3, u to the 3 over 2. And then I substitute the values in. And if I substitute 4 in, I get 4 to the power of 5 over 2, which is 32, times 4, divided by 5, which gives me 128 over 5. So 4 to the power of 3 over 2, which gives me 8 times 8 divided by 3. So minus 64 over 3, minus sticking 2 in. So 2 to the power of 5 over 2 is not going to give you something exact, but 2 to the power of 5 gives you 32, and then the square root of 32 is 4 root 2. So that times by 4 over 5 gives you 16 root 2 over 5. Let me write there. Hopefully you can see that. And then you plug the 2 in, 16 root 2 over 5, and then you've got 2 cubed, which we know is 8 root 8 times by 8 divided by 3 minus 16 root 2 over 3. And then when you simplify that, you get your answer. So if you take 32 over 15 outside, you just show its equivalent, and that would be your solution. So that would be using substitution. All right, now like if you looked at it and went, oh, there's something that differentiates to a constant, I want to use integration by parts. Let's see how we would use integration by parts. So for integration by parts, you're going to let your u equal 2x. Remember, it's the one that differentiates to a constant. Your v dash is x plus 2 to the power of a half. So therefore, when I differentiate that, I get 2. When I integrate that, I'm adding 1 to the power, 3 over 2, dividing by the new power, which will give me 2/3. And then my integration by parts formula is uv. So that's just going to give me 4/3 x plus 2 to the 3 over 2. And that's between 2 and 0. And that's minus the integral of these two multiplied together. So 4/3 x plus 2 to the 3 over 2 dx between 2 and 0. And that leaves me with 4/3 x plus 2, 3 over 2, minus, and when I integrate this, I'm going to add 1 to the power. So that's going to become x plus 2 to the 5 over 2. Divide by the new power, that's going to make that 8 over 15. And I can stick that all into my calculator in bits, and I'll end up with the same answer. So that's the other way to do it. If integration by parts is what you find easier, that's what I suggest you do. Okay, question 4. Okay, so we have here something over something, which we know is ln. The top is just a constant. So it's really easy to integrate these. We're just going to say 2 ln of whatever's on the bottom. And then you differentiate that. Sorry, that should be the modulus sign, which would give you 3, and you divide by it. Okay, and we've got that between 3k and k. So if we plug in 3k, we're going to get 2/3 ln. 3 times 3 is 9. So we're going to get 9k minus k minus 2/3 ln 3k minus k. And when we do that, we get 2/3 ln 8k minus 2/3 ln 2k. If we take 2/3 outside, lns we can divide by each other, 8k over 2k, the k's cancel, we get 2/3 ln 4, and we've proved it's independent of k. That just means there's no k in the answer, because we managed to cancel them out using our log rules. For part B, we're going to show it's inversely proportional, so we do the same thing, but it's not lns, it's got a squared on the bottom. So this is actually the same as 2x minus k to the minus 2 dx. So we're going to add 1 to the power. So we're adding 1 to the power. So we get 2x minus k minus 1, divide by the new power, makes that minus, and divide by the differential. So we're going to divide by 2. That's between 2k and k. If I simplify that, that's the same as saying minus 1 over 2x minus k. 2k and k. If I put 2k in, I get 2k minus k on the bottom. 2 times 2k, which is 4k. So I get minus 1 over 4k minus k, which is 3k, minus, sticking in k, so 2k minus k, which is k, minus 1 over k, which you've got minus 1/3 so minus 1 over 3k plus, which will give you 2 over 3k, which is proportional to 1 over k, because you've got the k on the bottom. So that's that one, and that makes sense. Okay, let's have a look at the next one. Okay. Right. Point P8 is the turning point. Okay, so mixing up differentiation and integration in this question. So we're going to start off by differentiating it in order to find the turning point. So we can use the product rule. So we've got u equals x, v equals e to the minus 2x, u dash is 1, v dash is minus 2 e to the minus 2x. We're going to cross multiply. So dy dx is going to be e to the minus 2x minus 2x e to the minus 2x. And we're going to make that equal to 0. So we're going to take e to the minus 2x outside, and we get 1 minus 2x. And then we rearrange that, and we can see x equals a half. Yeah, because e to the minus 2x is going to be 0. And that must be our point A. So x equals a half. To find b, we've got to substitute it back in. So y equals a half times e to the minus a half. No, it's just going to be to the minus 1, because it's minus 2 times a half. So that's just going to give you minus 1. That's 1 over 2e. So then that's, so your coordinates are a half and 1 over 2e. Okay, so now we've got to find the finite region. Okay, so what I'm going to do is just clear that so I can show you the diagram. So essentially what I can do is find out the area of this whole rectangle, which is in red, and minus for it this bit here. So I'm going to do the rectangle minus the area under the graph. To find the area under the graph, I have to integrate. So I'm going to integrate x e to the minus 2x between my value of a, which was a half, and 0. And I'm going to use integration by parts. So my u will be x because it differentiates nicely to 1. My v dash is e to the minus 2x, which integrates to minus a half e to the minus 2x. And I'm going to do x times uv essentially. So I'm going to get minus a half x e to the minus 2x, and that's already sorted between a half and 0. And I minus the integral of minus a half e to the minus 2x dx. So altogether, I end up with minus a half x e to the minus 2x, and then that's going to give me minus a quarter e to the minus 2x between a half and 0. And they want it as an exact form, which is annoying. You can't just plug it all into your calculator. So you get minus a half times minus a half, which is going to give you, so minus a half times a half, which gives you minus a quarter e to the minus 1, minus a quarter e to the minus 1. If you plug in 0, that becomes 0, but that becomes 1, because you get minus a half times 0 times 1, so that's all 0. And then you end up with minus a quarter times 1, so that's minus a quarter here. And that's the area under the, that gives you the area under the curve. So now we need to find out the rectangle, but first let's clean that up. So we get minus a quarter, so that's going to give you minus 1 over 2e plus a quarter. Now the entire area is going to be your a times b, So remember, A was a half and B was 1 over 2e. So we end up with, let's put it up here. So your exact area of your rectangle is going to be a half times 1 over 2e, which will essentially give you times the top and times the bottom, 1 over 4e. And so we've got a rectangle, which is 1 over 4e, minus the area under the graph, which was this bit here. I think my equal signs are maybe all in the wrong place. So minus a half e plus a quarter. And so your final answer will be a quarter plus a half, which is essentially 3 over 4e, minus and a plus, make a minus, a quarter. And that's your final area. Okay, so hopefully that makes sense. Next question. Right, so here they're telling you what they want you to use, so you can't even try use anything else. We're going to use the substitution, x equals u squared plus 1, but we follow the same thing that we were doing earlier. You just prepare everything first. So dx du is 2u, and you're going to be replacing the dx, so that's going to be 2u du. That's easy. We're going to do our limits. So our limits, we're going to have x and we're going to have u. So we know our x is 10 and 5. So if 10 equals u squared plus 1, 10 minus 1 is 9, take the square root, and it's telling you they're positive. So we get u is 3, and then if 5 minus 1 is 4, take the square root is 2. So we've got our other roots. So we can replace the x, so root, so what have we got here as well? We've got x minus 1, so x minus 1 is u squared, and root x minus 1 must just be u. Now we've got everything we need, so that's like our preparation work. We're going to sub it in. Instead of 10, we're going to put 3. Instead of 5, we're going to put 2. 3 can stay the same. Instead of x minus 1, we've got u squared. And instead of, so we've got 3 plus 2u. And instead of dx, we've got times 2u du. So we've subbed everything in. We can cancel out those u's. 3 times 2 is 6. And we've got our answer. So now we've substituted. So this comes up quite often. Once you've substituted, you've then got to use a different method. So substitution makes it easier. And what we can see is we've made it easier so we can use partial fractions. So if we clear that, so we've got a clear screen. So now we've got 6u3 plus 2u. Our first step is to rewrite that as a over u plus b over 3 plus 2u, which gives us 6 equals a multiplied by 3 plus 2u plus bu. And I can say u equals 0, so 6 equals 3a, so a equals 2. And then I can choose any other number. I could say u equals 1 if I don't want to use fractions. If I put u as 1 in, I get 6 equals 5a plus b, but I know a is 2, so 6 equals 10a plus b, so 10 plus b, so b equals minus 4. So now what I'm doing is I'm integrating what I found before. So it's not between 10 and 5. I found p and q, which were 3 and 2. And I'm integrating 2 over u minus 4 over 3 plus 2u du. Right, So that's going to give me 2 ln u minus 4 ln 3 plus 2u, but I have to divide by the differential in the bracket, which is 2, and that's between 3 and 2. And when I plug that in, I get 2 ln 3 minus, that's going to give me 2 ln 3 plus 2u, so that's going to give me 9, minus 2 ln 2 minus 2 ln 7. We can take 2 outside the whole thing to start with. We'd do 3 divided by, shouldn't be 19, it should be 9. 3 divided by 9 divided by 2 times by 7. So we end up with, so 2 ln 3 minus 2, so we'll get 3 by 9 divided by 2 times by 7, so that gives us 7/6. Because we only want it as 1 ln, we need to bring the 2 up as a power, so that means we square both of them, and we get ln 49/36, because they just want it as one value. And that's question 6. Question 7. Okay. A large spherical balloon is deflating. At time t, the volume of the balloon is modelled at decreasing at a constant rate. So decreasing, we're going to have a negative somewhere. Rate, remember that just means dt. What's decreasing? The volume. So dv dt is equal to minus some constant. I'm not purposely using k in case it like joins up and becomes anything. I know it's a spherical balloon, so I know the volume is 4/3 pi r cubed. So dv dr is going to be 4 pi r squared, but I don't want that. I want dr dt. So I want the r on the top, so I'm going to flip this one, so get dr dv to get the r on the top. And then if I multiply it by that, that is the same as that, because the v's cancelled and I'm left with that. So dr dt is equal to dr dv, which is 1/4 pi r squared, multiplied by dv dt. So we end up with, we want to end up with r squared on the bottom, which we have. And then we've got r squared on the bottom, but that's multiplied by minus c over 4 pi. So minus c over 4 pi, or c over 4 pi, must be equal to k. So where k equals c over 4 pi. Sorry, I just had a really weird noise. It's the time, it's 2:30 in the morning. Don't know, must be something in the garden. Okay. So we've got dr dt is minus k over r squared. Given that the initial radius is 40, after 5 seconds, solve the differential. Okay, you see the word differential equation. Your brain is going to go separate variables. So when you separate variables, you're going to bring the r squared up. So you're going to get r squared dr dt equals minus k. When I then bring the dt up, I straight away have to stick integral signs in. They get very lonely, drs and dt's, you can't separate them without putting the integral sign in. So the left-hand side, when we integrate it, we're going to get r cubed over 3. The right-hand side will become minus kt plus some c. And now we're going to try work out our k and our c using the information they've given us. So they've told us the initial radius is 40. So that means when t equals 0, r equals 40. And then we also know when t equals 5, r equals 20, which means we should be able to work out both values. So we'll get 40 cubed over 3 equals c. So c is going to give me, let me stick that in my calculator, 40 to the power of 3 divided by 3. So I get 64,000 over 3. And then I know when t equals 5, I've got 20. So 20 cubed over 3 equals minus 5k plus 64,000 over 3. So if I rearrange that for k, I get 20 to the power of 3 divided by 3 minus 64,000 over 3 divided by minus 5. So I get minus 11200 over 3. So my final answer is r cubed over 3 equals minus 11200 k, t even, not k, sorry, t, plus 64,000 over 3. Because everything has 3 in it, I can cancel those out. And we're done. Okay. Find a limitation for the values of t. Well, if I make the whole thing equal to 0, then we can't make the radius any smaller. So for example, if r equals 0, yeah, we can see that like minus 1200t equals plus 64,000 equals 0. So t would equal 40 over 7. So any t after 40 over 7 would result in a negative radius that doesn't make sense. Okay, next one. Question 8. So we've got parametric equations. So we're going to treat this is like a substitution question. So remember, the area under the graph is the integral of y dx between your x limits. So if I call that x2 and x1. So in this case, x1 is 0. x2, we need to work out what that is. So that's going to be, if we want to work out what it is, well, they've given us our range, so that's going to be pi over 2 and 0. We know what y is, so we can replace that, but we don't know what dx is. In order to do that, we need to differentiate the x. So x equals 6 sine t. dx dt is going to give you 6 cos t. Therefore, dx equals 6 cos t dt. And now you're going to substitute all of those into here. So you're going to get pi over 2 and 0. Y is 5 sine 2t times by 6 cos t dt. And then those trig identities come to haunt you everywhere. So we know that sine 2t is the same as 2 sine t cos t. We replace that here, and that's going to give us pi over 2, 0, 5 times 2 is 10, times 6 is 60. And then we've got sine t, cos t, multiplied by another cos t to give us cos squared t dt. And we end up with what we're looking for. So in terms of parametrics, they're actually quite straightforward. You just plug everything in. Okay, now this is one of the recognition ones. And I know sometimes they're the trickiest, but whenever you see either a sine or a cos being one greater power than the other one that it differentiates or integrates to, you can immediately go to what it'll be. So you go to the one that's the power higher. So in this case, it's cos. And you add 1 to the power. And you think about this. So you've got y equals, if it was cos cubed t, and I was to differentiate that, what would I get? Now remember, cos cubed t is just a fancy way of writing cos t all cubed. You'd bring the 3 down, take 1 away from the power, differentiate the bracket, which would give you minus sine t. So if you have a look, that means if I was to integrate this, I would go back to that. So the integral of minus 3 cos squared t sine t is equal to cos cubed t. Hence, the integral of cos squared t sine t dt is minus 1/3 cos cubed t. And we want 60 of these. So that's times both sides by 60. I'm just going to get 60 over 3, which is 20. So I can go straight to minus 20 cos cubed t between pi by 2 and 0. When I stick pi by 2 in, I get 0 minus 20. So then the exact area is 20, and I've shown that. And it's one of the proof by recognition. So one's the sine and cos cubed, the other one involves tan and sec squared. Okay, I think this is the last question for this batch. And this is the last one I'll do this evening, and I'll try to do another set tomorrow. So given that a is a constant, show that there are exactly 2 possible values. So let's take a look at this. This is the same as 3x to the power of a half plus a dx. So if we were to integrate this, we add 1 to the power and we divide by the new power. So we get 3x to the 3 over 2 divided by 3 over 2 plus ax between 4 and 1. So if I stick 4 in, I'm going to get, that's going to become 2 times 4 to the 3 over 2. So that's just going to give me 2 times 8 plus 4a minus sticking 1 in, which is going to give me 2 times 1 plus a. And so that gives me 16. Oh, 16. Let's do it this way. We know that all of this, let's just put it all in one go, is equal to 2a squared. So we get 2a squared, and so we're going to get minus 16, so 16 minus 2, which is 14, bring it all on to one side, so we're going to get minus 14, and then we've got 4a minus a, which is 3a, bring it on this side, gives you minus 3a equals 0. Right, isn't it? 2 times 8 minus 2, yeah, and then we've got 2a squared minus 3, oh, minus 14 equals 0. Oh, sorry, we don't actually need to solve it. We need to just show that there are 2 possible answers. So we need to show that b squared minus 4ac is greater than 0. So b is minus 3, 4 times 2 times minus 14. Which equals 9 plus 4 times 2 times 14. So 9. Okay, which gives me 121, which is greater than 0. And so they must be 2 real roots. The other way could be is that you factorize it and you show that you can get 2 roots. So let's see if we can factorize that quickly. You'd get 2a and a. So you'd get a plus 7, and you get, no, sorry, plus 2 and minus 7. Yeah, So you get a equals 7 over 2 and a equals minus 2. So that would be the other way to do it. Okay, I think that's it on this set. Hope that's useful. Like I said, it's a bit late. If I've made any mistakes, apologies. And hopefully everything will be up on Zahra Classroom as well in the next few days. Yeah, take care. Bye-bye.